Factors of the form x plus a into x plus b. Let us now discuss how we can factorize expressions in one variable like x square plus 5x plus 6, x square minus 7y plus 12, z square minus 4z minus 12, and 3m square plus 9m plus 6, etc. Observe that these expressions are not of the type of a plus b whole square or a minus b whole square. How we can identify that these are not of that type? Because here we have only one square term. 6 is not a perfect square. In second expression also we have only one square term. 12 is not a perfect square. Now such expressions are expansions of x plus a into x plus b. They are not perfect squares. For example, in x square plus 5x plus 6, the term 6 is not a perfect square. These expressions obviously also do not fit the type x square a square minus b square because there are three terms. And in second identity, in expansion we have only two terms. They however seem to be of the type x square plus a plus b into x plus ab. We may therefore try to use identity 4 studied in last chapter to factorize these expressions. So this identity can be used to factorize this expression. If we compare this right hand side, x square plus 5x plus 6, then if we compare each and every term, then this is exactly same. Here we have x, and what is value of a plus b? A plus b is equal to 5 and a into b is equal to 6. So what are values of a and b? The numbers whose sum is 5 and product is 6, those numbers are a and b. Here we can find 2 and 3, a pair of numbers such that their addition is 5 and their product is 6. So we can write this expression as x square plus 3x plus 2x plus 6. Now making groups of two terms, we can factorize it further. In first two terms we have x common. How we can find that x is a common? Because these x square can be written as x into x. This is our first term. Second term is 3 into x, then 2 into x, and now I will write this 6 as 2 into some number, that is 2 into 3. Now in this group we have x in both the terms, so we can take that x common. And now in bracket we will write remaining terms, that is x plus 3. Here we can take 2 common because that is present in both the terms. Here we have plus sign, then 2 into, as we are taking common, we don't write here plus, this is product. And here we have x plus 3. Now we have these two terms and they again contain same term, that is x plus 3. And the factor formed by other numbers is x plus 2. So the factors of x square plus 5x plus 6 are x plus 3 into x plus 2. Now this is very simple because each and every term is positive. There can be two terms negative or a single term negative. To learn how to factorize such terms, we have to revise addition and multiplication of integers. Observe here, when both the terms are positive, product is positive. When both the terms are negative, then also product is positive. When the product is negative, if the numbers have different signs. So whenever you get negative product, we must understand that these two terms will have different signs. One will be negative, other will be positive, because The product is negative only when the signs are different. Okay. Now if such two terms have different signs, then we perform the difference. Now let us try solving one problem. This one we have already solved. Now let us consider this one. Here if we compare it with our z square plus a plus b into z plus a into b, then what we have? Addition must be minus 4 and a into b product must be minus 12. We have to find out two numbers such that their addition is minus 4 and product is minus 12. Always the number will have its sign on its left side. So 12 is negative, 4 is negative. Now as we have product negative, product is negative if the signs are different. So the numbers which we are finding will have different signs. One will be positive and one will be negative. So I am going to write it like this: no change in first and last term. We are going to make two parts of this minus 4x, and one of them will be negative and other will be positive. Now in addition and subtraction, if the signs are different, then we perform subtraction or difference. So what we have to find out? We have to find out two numbers such that their multiplication is 12 and difference is 4. Now how to get that pair? We must know, or we must learn the tables for that, or we must be able to write 12 as a product of two numbers. I can start with 1 into 12, 2 into 6, 3 into 4. Now I have three pairs. They are, each one is having product 12, but each one will not have difference 4. Here the difference is 11, so we cannot use this. Here the difference is 1, so we cannot use this. So which is the suitable term for us? Suitable pair, that is 2 and 6. But just as we have concluded, these will have different signs, and now we have to decide which number will get which side. That is decided by this middle term. This middle term is negative, so your bigger number will get sign of that middle term. Which one is bigger in 2 and 6? 6 is bigger. So 6 will be negative and 2 is positive. Now we will write here 6z minus 6z plus 2z. Observe that if we are going to simplify this, signs are different, then sign of a bigger number and difference. Difference is 4 and bigger number is negative, so answer is minus 4. So you are not allowed to change this polynomial. You can make changes in that polynomial by keeping the given polynomial same. Now if we simplify this, these are like terms, you will get minus 4z. Now we can make the groups, can find out the common factors, and we will get two factors. Here z is common. After taking one z common, I have one z minus this z is taken common, so here we have minus 6. This 2z minus 12. 12 can be written as 2 into 6. As we have 2 here, suppose we have 3 here, then I will write this 12 as 3 into 4. But as coefficient in one term it's 2, we will write 12 as 2 into some number. Now what can be taken common? 2. Here we have plus sign, so we write here plus, and here it is z minus 6, which is again a common term. This is the common factor, and the factor formed by other terms is z plus 2. Okay. Now let us consider next question. Next question is my 7 plus 12. Here we have plus 12. Now this is y square, so let us change this variable. Now if we compare this with expansion of our identity, what we observe? A into B must be 12, means product must be 12, and A plus B is minus 7. Now our product is positive. When the product is positive, if both the numbers are positive or if both the numbers are negative. Now who will decide? Our middle term will decide. Middle term is negative, so the numbers which we are looking for will have minus signs. Both are minus because this middle term is negative and minus into minus is plus. That product is 12 over here. Now I will write this with two terms for minus 7y. Now in addition, if two numbers have same sign, then we add those numbers and the answer will have minus sign. So find out two numbers which are negative, their addition is 7 and product is 12. 1 into 12, 2 into 6, 3 into 4. Here each pair has product 12, but here addition is 13, here addition is 10 and here addition is 7. So this is our required pair. Only one pair will satisfy both the conditions. So what are our numbers? They are minus 3 and minus 4. So we will write here minus 3y minus 4y. Now let us form the groups. Y can be taken common. So this is y minus 3. Now whenever your third term is negative, we have to take negative term common. Actually when we take a common term, what we perform? We have here y square, that is y into y minus 3y. We divide both the terms by our common term. Y into y upon the common y. So we have y. Then this 3y upon y, this y will get cancelled and here we get factor as minus 3. Same thing we are going to perform thus for this. Minus 4 into y and plus 12. Minus 4 is taken common because 4 is factor of 12, so we can take minus 4 common. And now divide both the numbers by minus 4. This minus 4 divided by minus 4 gives you 1 and we have this y. And in division, like multiplication, if the signs are different, answer is negative. Here signs are different, so answer is negative and that is minus 3. Now this is a same factor. So this is y minus 3 and second factor is y minus 4. So this is how we can factorize the terms which do not contain both the square terms. Here in exercise, these are the questions based on first two identities, because this is square, this is square, 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 square. So these questions are based on a plus b whole square and a minus b whole square. Here these are on a plus b into a minus b, that is a square minus b square. Here we have to take common term and then we can get the factors. Here also we can use both the or three identities. Which are these three identities? A plus b square, a minus b square, or a plus b into a minus b. Now this fifth question can be solved by using our identity x plus a into x plus b. So we can solve these questions by using the topic which we have discussed here. Okay.